Investigating CO2 and O2 concentrations in different environments. Word limit. 10 to 15 words. Rationale. The title should remain concise yet descriptive enough to convey the focus of the experiment. Introduction. Background research. Word limit. 300 to 400 words. Rationale. This section should provide a comprehensive overview of the relevant scientific concepts, including more detailed explanations and context to better set the stage for the experiment. Summarize the importance of CO2 and O2 in the atmosphere. Discuss their roles in essential processes such as photosynthesis, respiration, and the greenhouse effect. Provide historical context and theoretical background relevant to the study of atmospheric gases. Explain how knowledge of CO2 and O2 concentrations can be applied to address issues related to air quality, climate change, and environmental health in both familiar and unfamiliar situations. Critically evaluate the sources of your background information. Compare the accuracy and reliability of data on atmospheric CO2 and O2 from different scientific studies and online resources. Research question. Word limit. 30 to 50 words. Rationale. The research question can be slightly more detailed to include the rationale behind the question and its significance. Formulate a specific research question. Example. How do the levels of CO2 and O2 in various school environments compare with those from online global data? And what implications does this have for air quality? Hypothesis. Word limit. 75 to 100 words. Rationale. The hypothesis should include detailed reasoning and context, allowing for a more thorough explanation of the scientific basis behind the prediction. State a clear, testable hypothesis. For example, the concentration of CO2 in classrooms will be higher than in the school garden due to human respiration. Provide the scientific reasoning that leads to this hypothesis, including principles related to human activity and plant photosynthesis. Methodology. Word limit. 75 to 100 words. Rationale. A more detailed list of materials, including any specific brands or models of equipment used, can be provided for clarity. Materials. List all materials required for the experiment, including CO2 and O2 sensors, data recording sheets, and access to procedure. Word limit. 200 to 300 words. Rationale. The procedure should include more detailed steps, explanations of why certain methods were chosen, and any potential troubleshooting or adjustments made during the experiment. Describe the step-by-step procedure for collecting CO2 and O2 data in 4 classrooms, the school garden, and from the online source. Detail how you will control variables such as time of day and ensure consistent data collection methods. Variables. Word limit. 75 to 100 words. Rationale. Provide a more detailed explanation of the independent, dependent, and controlled variables, including how they were maintained or measured. Identify the independent variable, dependent variables, and controlled variables. Data collection. Raw data. Word limit. 100 to 150 words. Rationale. Provide a brief description of the raw data and any initial observations. While the bulk of the information is still presented in tables or figures, record all measurements in a clear and organized table, noting the time of each measurement and the units used. Present this data in its raw form before any processing. Results. Word limit. 200 to 300 words. Rationale. This section should include a more in-depth analysis of the data, exploring any patterns, anomalies, and their possible explanations in detail. Data analysis. Calculate the number of moles of CO2 and O2 for each data point using the ideal gas law. Present this data in tables and graphs. Analyze trends and patterns observed across the different environments. Discussion. Conclusion. Word limit. 150 to 200 words. Rationale. The conclusion should provide a thorough discussion on whether the data supports the hypothesis, with detailed references to the data analysis and background research. Reflect on your hypothesis and discuss whether the data supports or refutes it. Provide a detailed explanation based on the analyzed data. Validity of method. Word limit. 150 to 200 words. Rationale. Provide a more detailed evaluation of the methodology, discussing potential sources of error, limitations, and the reliability of the results. Critically assess the methodology used for data collection. Identify any limitations or potential sources of error that could have affected the results. Improvements. Word limit. 100 to 150 words rationale. Suggest more comprehensive improvements or extensions to the experiment, including how they could address the limitations identified. Suggest realistic improvements or extensions to the experiment. Discuss how additional data or alternative methods could enhance the accuracy or scope of the investigation. Reflection word limit, 150 to 200 words rationale. Reflect on the broader implications of the findings in a more detailed manner, relating them to real-world issues and the significance of scientific inquiry. Impact of science. Reflect on how the scientific inquiry process relates to the findings of your experiment. Discuss the practical applications of your results in real-world scenarios, such as improving air quality in school environments. Broader implications. Word limit, 150 to 200 words rationale. Discuss the societal, environmental, or technological impacts of the findings in more depth, considering future research possibilities and ethical considerations. Consider the broader societal, environmental, and technological implications of your findings. Discuss potential future research prompted by your results and any ethical considerations involved. Communication of scientific concepts. Word limit, 75 to 100 words rationale. Reflect on the effectiveness of the communication of scientific concepts throughout the report, with a focus on clarity and precision. Throughout your report, use appropriate scientific terminology to clearly explain complex concepts. Ensure that your communication is precise and understandable. References. Word limit. No limit rationale. Cite all sources thoroughly, with complete references to ensure academic integrity and proper attribution. Cite all sources used in your research, data interpretation, and conceptual understanding. Include full references following the appropriate citation style. Appendices. Optional. Include any additional information, such as extended data tables, detailed calculations, or supplementary material. Notes. In this experiment, identifying the dependent and independent variables is crucial for understanding how to design and interpret the experiment effectively. Here's a description and explanation of both. Independent variable. The independent variable is the factor that you, as the experimenter, change or control in the experiment. It's the cause or condition you want to test. Example in this experiment, location of measurement. The independent variable in this experiment is the location where the CO2 and O2 levels are measured. You will be measuring these levels in 4 different classrooms, the school garden, and comparing them with global data from explanation. By varying the location, you can investigate how the environment influences the concentration of CO2 and O2. The different environments provide distinct conditions that might affect the levels of these gases. Dependent variables. The dependent variables are the factors that you measure in the experiment. These variables depend on the independent variable and are the outcomes you observe in response to changes in the independent variable. Example in this experiment, concentration of CO2 and O2. The dependent variables are the measured concentrations of carbon dioxide and oxygen in parts per million in each of the environments. Explanation. The levels of CO2 and O2 are expected to change depending on the environment where the measurements are taken. For example, a classroom might have higher CO2 levels due to human respiration, while the school garden might have higher O2 levels due to photosynthesis from plants. By measuring these levels in different environments, you can analyze how the independent variable affects the dependent variables. Summary. Independent variable, location of measurement. Dependent variables, concentrations of CO2 and O2. Understanding the relationship between these variables will allow you to determine how environmental factors influence the levels of CO2 and O2, leading to more meaningful conclusions and reflections in your experiment. Connection to C.PM. Structure and properties of matter C.PM.11. Atomic structure and properties of matter, properties and locations of subatomic particles. Explanation. CO2 and O2 are both molecules composed of atoms, which consist of protons, neutrons, and electrons. Understanding the basic atomic structure helps explain the behavior of these gases at the molecular level. Connection to experiment. When measuring the concentrations of CO2 and O2, you are essentially working with substances made up of atoms and molecules. The experiment offers a practical application of understanding how the atomic structure influences the behavior and properties of these gases in different environments. 2. Evolution of atomic models theory. Development of atomic models. Explanation. The evolution from early atomic models to the quantum mechanical model provides insights into the behavior of electrons in atoms, which in turn affects the properties of molecules like CO2 and O2. Connection to experiment. Reflecting on how atomic models evolved helps students appreciate the complexity of predicting and measuring molecular behavior, such as the concentration of CO2 and O2 in different environments. This ties the practical experiment to theoretical developments in chemistry. 3. Electrons and electron configurations. Electron configuration and chemical properties. Explanation. The electron configuration of an atom determines its chemical properties, including how it bonds with other atoms to form molecules like CO2 and O2. Connection to experiment. Understanding the electron configuration of the carbon and oxygen atoms in CO2 and O2 molecules allows students to comprehend how these molecules interact with the environment, influencing their concentrations in different settings. 4. Quantum mechanical model and electron energy levels. Discrete energy levels for electrons. Explanation. The quantum mechanical model describes how electrons occupy discrete energy levels, which affects the absorption and emission of energy. This concept is crucial for understanding the interactions between molecules and light, such as in the absorption of infrared radiation by CO2, contributing to the greenhouse effect. Connection to experiment. While measuring CO2 concentrations, students can relate this data to the broader implications of CO2 as a greenhouse gas, which ties back to the quantum mechanical model's explanation of how CO2 molecules interact with energy at the atomic level. 5. Practical applications of atomic concepts. Use of atomic models to predict properties. Explanation. Atomic models are used to predict the behavior of atoms and molecules, including their interactions in various environments. Connection to experiment. The experiment serves as a practical application of using atomic and molecular knowledge to understand environmental chemistry, such as how CO2 and O2 levels vary based on location and conditions.